Okay, welcome everybody. Today I'll be presenting a webinar on anonymous functions in PHP 5.3. My name is Matthew Weir-Elfini. I am project lead for Zen Framework. One reason I'm giving this webinar is that we have been using closures either within code for Zen Framework 2 or in prototyping code for Zen Framework 2. And I wanted to share with you some of the tips and tricks I've learned, but also just basic usage, terminology, and a few other things that you may want to know and be aware of. So first off, you need some vocabulary. You're going to be hearing about anonymous functions in a variety of terms and situations, ranging from lambdas to anonymous functions to closures. And they each have a slightly different meaning. Some of them are pretty much interchangeable, but it's good to know what it is you're actually working with. So to start off with, we'll talk about lambdas, and they come from a type of mathematics called lambda calculus. Within lambda calculus, the names of functions are just merely a convenience, and as such, all functions are actually considered anonymous. The idea is that you should be able to sling them around or chain them together and not have to worry about what they are, what they're named and everything. You just use them. You'll see these typically in true functional programming languages like Haskell, F#, OCaml, and that sort of thing, where functions are actually first-class citizens of the language. In PHP, they're not, and it may seem like they are because we have a lot of them, but with a true functional programming language, a function is actually a type of object within the system, and they're not within PHP. As such, we're typically using what are called lambda expressions, something that expresses functionality within the system, but doesn't have a name. So it's an anonymous function. So in this case, lambdas and anonymous functions are typically interchangeable. There's a few other things that differentiate lambdas. Quite often lambdas, the assumption is that you never need anything more than one argument. So you'll do currying and that sort of thing. We'll talk about currying later. But for our purposes with PHP, we can simply say lambda or anonymous function, and it means approximately the same thing. Now, closures are slightly different. Closure is a function that includes a referencing environment. And what I mean by that is each function has its own scope, but it also allows you to pass in objects or what we call import objects, which allows you to hide state. So there's some interesting things you can do with that, and I'm going to show you examples later. The main thing here to get across, though, is that you might have, for instance, a log object that you import into a closure, and so now the log already has state, and you're able to do things with that state as it was defined as you continue. So the real differentiating factor here is when we talk about a closure, we're talking about an anonymous function that has some sort of stateful object within it that was defined at the time of creation and then used when the function is called. Again, we're going to see examples of all these, but I want to get the terminology out of the way. Anonymous functions then are just any function that is defined or called without being bound to an identifier. When I say bound to an identifier, I mean it's named. So typically, if you look at PHP, we have a lot of functions like, stir replace or stir comp or those sorts of things. The identifier there is what we're talking about. Those are named. Now, you can assign a function, but that's not the same as having it bound to an identifier. So we can assign a function to a variable, but we're not actually giving it its own name in this particular case. So with the vocabulary out of the way, we'll now look at PHP's offering. And I'm going to start off on a tangent here because it's necessary to understand how the anonymous functions work within PHP. The first thing are functors. And in PHP 5.3, this is a new functionality. It's basically, there's a new magic method that you can declare on objects that you define called __invoke. When you define that method, if you have an instance of the class, you can now simply call it as if it was a function. So in this particular example here, we have a class called command, and the command class defines this __invoke. And it accepts an argument in this particular case. What we do now is if we get an instance of the command, so C equals new command, and then we can simply call that as if it were a function. So I say C Matthew, and it will now say hello Matthew. So this is an example of a functor. This is a really nice functionality because we can actually have these nice encapsulated objects that now act as if they were functions, which is a really nice system for like helpers where you may want to go and set up the state and everything and then use them over and over again with that particular state. Now, anonymous functions are interesting because they build off of invoke. A new class was added to the PHP core called closure, and that class actually defines __ invoke so that you have a class that's invocable. What happens is the body of this is pseudo replaced with the defined function that you define as your anonymous function declaration. I say replaced because it's not really the case, but what happens is that functionality is invoked via the invoke method with appropriate arguments. And what it does is it does some composition and other things in order to make this work. Now, the ability to bind variables via imports happens, so that allows us to create actual closures, which is why this is called a closure class. It's stateful. We can actually provide context to the particular anonymous function in order to call it, make it a closure. What's interesting about this, I'm going to actually go back for a second, is that it's called a closure class, but we can define both regular anonymous functions, so something that is just not bound to a name that isn't stateful, and we can also create actual closures which have some sort of a knowledge of the scope and context in which they're called. So things to know about the PHP implementation is that in most cases, anonymous functions behave just like normal PHP functions. And the variables that occur with them happen in their own scope. So you don't have the global scope bleeding into it like you might have with JavaScript, for instance. So that's a very important thing to know. Next thing, you cannot import $this. It will throw an error. And this is problematic for those of us who want to experiment with monkey patching our classes. I'll show you some ways that you can get around it later, but just be aware that you cannot import $this. The other thing is you cannot alias imported variables. So namespaces, you can say, I want to import this class as this particular alias. You can't do that with PHP. Now, some of this you're probably going, oh, what are you talking about? I'll give you examples in a few minutes, but I'm going to come back to this as we look at the examples. But you can't alias them. So if you define a variable as $log and you import it, it has to be $log within the anonymous function. So knowing that, you may need to do a little bit of reassignment or assigning of new variables if you need to have different variables within your anonymous function. So now let's turn to the syntax here. You notice I'm calling it anonymous function and closure syntax. Those are the two use cases that PHP provides. So with your basics, you're simply declaring a function like you normally would, except there's no name. You just say function, and then you give the arguments to the function and then the body of it. Notice I'm terminating with a semicolon. If you are doing this as part of a statement, then you have to. Now, by itself like this, it's of no use whatsoever because there's no way to call it, and that's the problem. So you will often assign it to a variable. So again, don't forget the semicolon terminator, but here we have greet is a variable, and we're assigning an anonymous function to it. So we've got function with an argument of name, and we'll say hello name within that. And so now I can say greet Matthew. So this is a nice fluent usage of the language. It's neat in many ways. Maybe not terribly useful, but what is useful is being able to pass it around and call it over and over again without necessarily needing to name it. So I mentioned passing it around. You can pass it as an argument to other callables. Now, in this particular example, I'm defining the anonymous function in line. I could have also defined it and assigned it to a variable and passed it as well. So we've got a number of different ways to do this. So the first thing we have is we have a function say that's defined elsewhere that accepts a value and a callback. And what it's going to do is it's actually going to call that callback with the given value. not a very good example here, but it gets across some of the things I'm trying to explain. So we say for the value is Matthew, and then our callback is an anonymous function. So the anonymous function is just like we had in the previous example, and it accepts a name, and then we return hello name. So in this particular case, we return that, and then say is going to actually echo it. So it's fairly straightforward, very succinct. So hopefully what I'm hoping you're going to see here is that there are a number of cases within your actual code where you don't really need to define a function that needs to be reused, but you need to have something that you just need to use once and throw away, and maybe it'll be iterated over whatever, but you don't actually need a function name for it. And this is where anonymous functions come into play. Now, let's look at closures. We've been looking at anonymous functions, so these don't have any sort of scope. As you use it, it's basically accepting arguments and it's returning or doing something. But each time, if you give it the same values, it will do the same thing. Now, with closure, you're actually going to pass in some context. And in this particular case, I'm going to pass in a log object, and I'm going to operate on it. So what will happen is I'm going to bind a variable at creation and then use it at call time. So I get my log object somehow. So in this case, I'm using Zenlog factory and passing it some configuration. And then logger is going to be a callback. And that callback is not going to define what the arguments are up front, but it will use log within it. And I will grab all of my arguments using funcGetArgs. I will then JSON encode those so I can actually utilize it within the logger. And log is going to simply log it at that point. So there's no side effects, there's no return value from this particular one, but I can actually attach this just about anywhere. So if I say logger foo bar, I will now have a JSON encoded string of foo and bar, which is actually pretty cool at this point. Now, you'll see here, there is some state. We have the log object itself, and so it's aware of a bigger state, and this becomes really interesting as we look at some of the use cases later on. We can basically provide cross-cutting concerns in this way, where the actual objects don't need to know what it is that they're invoking. They just invoke it, and then that part is stateful and has some knowledge of other objects in order to compose different functionality. So some fun things to try. Let's start with array operations. We'll look at some sorting operations, walking, mapping and reducing, and filtering. I'll go into what each of these are as we hit each of the examples. But these are some of the common use cases for using anonymous functions and closures. So I'm going to start with sorting. There are a variety of methods for sorting. You can sort on the values, on the keys, on a combination of both of them. And in most cases, there are U variants, which are user variants, where you can actually specify the functionality to use in order to affect the sorting composition. So in this case, what I'm going to do, this actual callback isn't necessary. I could always just use a stir case comp, but it shows how I might utilize an anonymous function in this particular case. Usually when you're doing sorting, you don't actually need the function. In fact, the only time it's going to be used is with that particular usort or other operation. It's not going to be used elsewhere within your code. So defining a new unique function or static method or whatever is a little bit over the top in many of these cases. And so it's a perfect example of where an anonymous function really shines. So in this case, we have defined an array of stuff that includes apple, anise, applesauce, and appleseed. And what we're going to do in this particular callback is we're going to compare values using stir case comp, which is a case-insensitive comparison. And it goes and sorts it, and stuff then gets sorted, and there are new indexes and everything. Now, if we look at it afterwards, we'll see it comes out anise, apple, applesauce, appleseed. And you'll notice that it's a mixture of uppercase and lowercase in terms of where they sort out. So that's fairly straightforward. Another case is walking. Now, walking is an operation which allows you to actually change the values in an array. So it doesn't return a new array, it actually operates on the values in the array. Knowing that if you're not using objects within as the actual array values, you're going to need to pass by reference, and you'll see that within the example here. So we start with the exact same array of stuff, and in this case, ArrayWalk is going to take that same array and define a new function. And you'll notice the pass by reference here with value. You've got the ampersand indicating I want a reference to the original value. And in here, I'm going to say value is stir to upper of value, and that will actually change it within the array itself. And now we have all uppercase apple, anise, applesauce, and apple seed. Very straightforward at this point. Now, mapping is where we start getting into a paradigm called functional programming. I went to a code camp in Burlington, Vermont this past fall, and we had basically an open source track where we looked at a variety of languages and went through and said, the format was, going through the syntax and operations that a typical developer might need to get started to know the language. One of those languages was C#, and that one had to vary entirely from the rest of the languages because it was the only functional programming language that we utilized. Now, where does that come in? Well, with functional programming, basically the paradigm that you have is with procedural language, you would say, for instance, if I want to make a cup of coffee, is I go to my grinder, I put some coffee in the grinder, I grind the coffee, I put the coffee in the machine, I add water to the machine, I operate the machine, and now I have my coffee. With functional programming language, you would just say, get my coffee, and expect that it would come back. And what happens is you use a variety of what are called map and reduce operations that take this data set or set of data and performs mutations on them. And usually these are chained together. So the results of mapping are then passed to reducing, and then you get the result at the end. Now, the only person then who's worried about the internals is the person doing the programming. But in terms of consuming the product, you're simply passing in some values, and you expect to get some data at the end. Now, mapping is similar to ArrayWalk in that it performs work on each element, but what it does is it creates a new array. So your original array is not altered, and this is one of the real tenets of functional programming, is that you don't actually alter the data, you just go through and process it and return some data at the end. So mapping is going to work on each element and return a new array. So we're taking the exact same example that we had with ArrayWalk, and now we're going to do a mapping operation on this. Now this is an interesting one because ArrayMap, now you provide the callback first and the array of values second. All the other examples I have in here, you provide the array of values first and then the callback. I'm not quite sure, other than I think this is how typically MapReduce works, is that it is expecting input into the operation, and so you're just defining the callback. So in this case, we have mapped, so now we're actually assigning the return value of ArrayMap. If we don't do this, we don't have anything to operate on. So we do this, and you'll notice that I return the value at the end. So I transform the value, I do whatever I need to do, and I return it. And then that populates, the return values are what populate the array. So my stuff array, as you'll see, remains unchanged, but mapped now has all uppercase versions of this. So now we'll go into reducing, and what reducing does is it combines the elements and returns either a unique value or a data set. And it goes through and does transformations is the way I look at it. So mapping is mainly trying to figure out, what data do I want, and reducing is more about, now that I've got that data, do something interesting with it. The return value that you have is returned as the first argument of the next call in all cases. Within PHP, you typically will then need to actually seed the return value, and array reduce, the arguments you absolutely have to have are the array of stuff as your first argument, and then the callback as your second argument. The third argument is what you use to seed that value that's going to be returned on the end of each call. So I'm taking, again, the example of my array of stuff, and in this particular case, you'll see that the function count is what is going to be passed back and forth, and then input is whatever is coming in off of my array of stuff. So my count is going to be incremented by every time I find a lowercase a within the input that comes in, and then I return that count at the end. So I start with 0. And as it goes through that array of stuff, it increments that. And you'll see with Apple, we'll get 1 value because we have an A in there. Annie's doesn't have any, so we get 0. Applesauce has another A, and Appleseed has 1. So we have a reduce is going to be 3 at this particular case. So reduce operations, map and reduce, you're going to see a lot with document and key value databases. So within your NoSQL databases. So CouchDB relies solely on MapReduce in order to do querying and filtering operations. Mongo has the ability to do MapReduce operations as well, and it's particularly useful for doing things like comment counts or tag counts and that sort of thing. You can mimic all this stuff within PHP as well, utilizing array map and array reduce. And again, anonymous functions or closures are a really nice way for you to operate with that functionality. Filtering goes along with MapReduce, in my mind. With filtering, you return only the elements that evaluate to true. So it's often used as a form of mapping to go through and determine, okay, what elements am I interested in this particular case? And then I pass the results of that to my reducer. So I'm going to start again with my array of stuff, and I messed this up on the slide. I have the wrong example here. It should be array filter, and the arguments are exactly the same in that you have your array of stuff, and then your function is actually going to operate on just the input. So in this particular case, what I was doing originally in this example was that I was checking for an element that had a lowercase a. And so when I did my array filter, I ended up with just apple, applesauce, and Appleseed. Annie's was tossed out of there because it did not have a lowercase a. So I had a smaller subset of items within my array. Now, we've been looking at array operations. There are a number of other places within PHP that closures come to mind, but perhaps the most important one I can see is with regular expressions. So with preg replace callback, and we'll take a look at that. And then also currying arguments, and this is usually interesting with string operations, particularly when filtering. So looking at preg replace callback, what's interesting about this is that it allows you to transform the matches that you capture with your regular expression and do something interesting with them. So in this case, I've got today's date next month is, and I'm giving actually today's date. So that doesn't work, right? But what I can do is I can say, hey, I can do something fun with this, and I can go and do a preg replace callback. So I'm going to look for that date string, and this is a really nice one because it's easily captured. So you'll notice the parentheses are used in my regular expression, and whenever you have parentheses, that's capturing. So now I'm looking for 4 digits followed by dash, followed by 2 digits, followed by dash, followed by 2 digits. And I'm going to capture that. Now the second argument to preg replace callback is a closure, or actually not a closure, but any sort of callback. And in this case, I'm doing an anonymous function. So in here, I'm grabbing my date time, and you'll notice I've got the matches are passed. So if you're familiar with preg replace, the third argument that you can do is specifying an array that you want the matches captured in. With preg replace callback, the assumption is that your function, your callback, is going to receive that array of matches. So I'm going to grab the first one off of there, which is going to be my date, and use that to see the date time object, and then I'm going to use a date interval to add 1 month to it, and return the formatted date. And of course, I'm operating on the string that I started with. So today's date next month is 2011-05-26. So that's a really interesting use case as well, as transformations of the captured values of your regular expressions. Now, currying is a fun thing, and a lot of people are going, well, what does Indian food have to do with any of this? And it has nothing to do with it. But in many cases within your anonymous functions, you may want to provide some default arguments. So it might be to reduce the number of arguments needed, so you may know what the other arguments need to be. You might want to supply values for optional arguments. So for instance, the method or function call may only have 1 or 2 required arguments, but you may actually want values for those optional ones. Or you may be simply wanting to provide a unified signature for callbacks, in which case you may put in a little bit of state by actually creating a closure that has some knowledge of an environment. So for instance, the current encoding or character set that you're utilizing, that sort of thing. So as an example here, HTML special chars is one of those where usually we know what the last 3 arguments should be for our given application. And all we really worry about is the actual value. So I'm defining a variable HS, short for HTML special chars, and its value is going to be, in this particular case, an anonymous function. And it accepts a single value. And now what it's going to do is it's going to return the return result of HTML special chars using that value, but hardlining the int quotes for the quote encoding, UTF-8 for the character set encoding, and then the last value is false to prevent double encoding. So if it already found character entities within the string, it won't try to double encode them. So in this case, I say filtered equals HS, and this is where I'm using it as if it were a function. So HS is my filter, and I've got some HTML mixed in with the string. I've also got a quote in there, and the result you can see on the last line there. So fairly straightforward. Creating arguments is actually really powerful. I use this all the time because it allows me to prototype and say, okay, I think this is what the signature should be. Oh, wow, this function or method that falls outside that signature, but it could still be useful in this particular case, so I'll just create a lambda. So we've seen a lot of use cases. We've gone through the basic syntax. I'm going to go through some gotchas now, because any technology that you have, there's always some, along with the benefits, there's always a few problems that pop up. One of the first ones that pops up are references. The variables passed to callbacks, either as arguments or imports, are not passed by reference, unless, of course, they're objects. So just like regular functions. So use objects if you are worried about the values changing and being able to report the changed values outside of the scope of the function, or pass by reference. And of course, with pass by reference, that doesn't mean pass the value, with using reference, but define it properly. So in this particular case, I'm looking at 2 different things, both the value passed into the closure as well as the scope I'm importing into the closure. So I'm defining count as 0, and then my counter is going to be a closure, and it's going to accept a value, and I want to be able to transform that value. And I'm also going to use the count from the current scope, and I want to be able to transform that. So in both cases, I'm passing by reference. If I have an integer value, then what I'm going to do is increment my count by that value, and I'm going to reset the value to 0. So it's a purely contrived situation, but it shows it off very easily. My array of stuff includes the string foo, the integers 1 and 3, and the string bar. And when I do an array walk on this now, utilizing counter as my callback, what happens is my stuff array has now changed, and those integer values are now 0. And my count has also changed. It's now 4, because we had 1 added, 0 added to 1 added to 3. So now we have 4. So that's one thing to remember. If you need the value, and you know that the value is going to be scalar, and you want it to be able to change, make sure you pass it by reference. Next thing, quite often closures are useful in situations where any callable is useful. So when I say any callable, we're talking not just closures and anonymous functions, but also callbacks. So it might be a static function reference. It might be an array referencing an instance method off of an object. It might be a string indicating the name of a particular function that you've written or which is available within core. Those are all callable. However, each of them can be called differently, and this is where things come to a head. So in this particular case, a few things to think about. First off, the class closure is actually considered, quote, an implementation detail by the PHP folks. I actually quoted that because that's within the PHP manual itself. So typing on it excludes other callback types. For instance, functors are also callable. So that's something to keep in mind as you look at this. Is callable, so if we don't type in on closure, but instead on is callable to tell us whether or not it's callable, that only actually tells us how it can be called, not how. I mean, that it can be called, but not how. We'll go into the hows in a minute. If we use is callable and is object, we now know we have a functor, which could also be a closure, but it means every other callback type that we may have available. And those are all valid callback types and may be useful within your particular use case. So there are three different ways to call callables. I'm going to go through each one and what the pros and cons are. Now, if we have a closure or a functor, we can say object and call it as if we're a function and arg1, arg2. Now, the benefit of this is speed. It's very fast. It's as fast as calling a function, basically. The problem is that unless we have a functor or a closure or a static method call, this won't work. So for instance method calls, won't work. If we're using a string function name, won't work. So that's something to be aware of. So now we'll move on to the second way, and that's call user func. And in this case, the first argument is always the callable, and then you have an argument for each argument you want to call on it. Now, this is very fast as well, and it works with all callables. It's slightly slower than the direct call that we had before, but it's negligible. And it works with all callables. This is great. The problem is, and there's always a problem, what if we don't know the number of arguments until runtime? Things get a little difficult at that point, because now you have to have complex switch statements, that sort of thing, in order to try and figure out how many arguments there were and to build up your call user func declaration. It's not easy, and I remember building up all sorts of things until I ran into our third way to call things, and that's call user func array, in which case your callable is the first argument, and then the array of arguments to pass to it. So this is really nice. This solves a lot of problems. It's lovely. It works with all callables. It works with variable argument counts. Everybody's happy, except for speed. It takes up to 6 times longer to execute a callback using call user func array than using a straight call. Now, that won't be a problem in many cases. However, if you're using a framework or your code is relying on a lot of dynamic calls like this, that's when it becomes problematic. Good cases to show this are, you have a lot of helpers, you have a lot of partials, that sort of thing. This is going to get expensive relatively quick. So be aware of that as well. There are 3 different ways to do it. You may be able to mix and match. One of the things I've done is using a switch statement to see how many arguments I have, and up to like 3 or 4 arguments, building out the actual calls so that it can be relatively fast. And then after that saying, okay, I've got too many to deal with, I'm just going to call user func array. So that's something else to think about. Now, I mentioned towards the beginning, before we went into the actual syntax, that you cannot import $this. Now, we've looked at importing now. It's where you say use, and you use a variable from the current scope. Creative developers will then say, ooh, what if I could import $this? Now, all of a sudden, I can basically monkey patch my classes. Yeah, you can. You can monkey patch. That's good, but you can't use this, which means that you're going to be limited to public methods. And I'm going to show you a way that you can do this sort of monkey patching where you go and alter the object to a certain degree. But you have to be quite aware that you're limited to public methods whenever you do this. Also, you can't actually overwrite a method call. Anytime that it sees that you're calling it something that looks like a method, it's going to have preference on that over your properties. The last thing is you can't auto-dereference closures assigned to properties. That means you can't say object and then the name of the callback and just expect to be able to call it as a function. It doesn't work. you have to dereference that. So that means assigning it to a new variable that's not an object notation, and then calling it as if it were a function. So to see what I'm getting at here, we've got a class foo, and what I'm going to do is I'm going to basically look at all of the various pieces we had back there. In the first part, we have a constructor, and we want to define a bar pseudo method that's a callback. In order to do this and have access to the $this object, what I'm going to do is I'm going to assign $this to $self. Those of you who have done any Perl will be laughing at this example because $self is how you usually refer to the object within methods of an object in Perl. So this bar is going to be a function. It's going to use $self, and it's going to return get object varies on self. It's not a semantic name, obviously, but basically what we're going to say is any variables that we have, I want to return that array of variables when I call this bar. Now, I can't actually call that as a method. I actually have to say, I have a $f instance, and I would say bar equals $f point to bar, and then I could say $f, and you call it as a function. Bizarre stuff, but you can do it. Next is add method, and add method I'm going to basically take the name, and that's going to be the property I want to assign a closure C to. And what we're going to do is then define underscore call, a magic method for overriding. So this gets invoked anytime a method is called that it doesn't know about, that's not actually defined. And what we do in here is we say if property exists and is callable, then what we will do is we'll actually do something with it. Now, our callable is then this method, and we can call that directly, and we say pass that as the callable to call user func array, and then we pass the arguments. So as you'll see here, we are dereferencing in this particular case because it's getting passed as an argument. So we're not actually calling it as if it were a function. So we can see now you can do the monkey patching. Just be aware that you have to do some odd things. With this in place, we can actually call this bar, and it will call it as if it were a method. And we can do that for anything that we add via add method in this particular case. Now, this looks like a lot of fun, and it can be. I do want to caution you that as much fun as it can be, it also makes the code harder to understand for people coming in later. They're like, well, where did this get defined? I don't see it in the API docs, that sort of thing. So be very careful when using this. Make sure that you have a really good use case for doing it and that you've also documented it really well. Now, the last problem that we come upon is serialization, and it's straight off. You just can't serialize anonymous functions. So if you're going to be serializing objects that compose anonymous functions, you need to be aware of this. And when I say compose, like assign them to properties, that sort of thing. You can't serialize them, and so you'll have to redefine them at some point within your code. So be aware of that as you play with anonymous functions. There are limitations. Now, there's some really fun use cases, and one of the use cases that I think is most interesting for utilization of these is aspect-oriented programming. Within aspect-oriented programming, we're defining aspects, or code that cuts across the boundaries of many components. And then aspect-oriented programming formalizes a way to join aspects to other code. So an example is a logger, something that has cross-cutting concerns. And you don't necessarily want to compose a logger into all of your objects, but you may want to be able to attach it somehow and have it get called. One of the things, too, is that you'll often need to query arguments in order to maintain signatures. So you might have the same aspect across a whole bunch of different pieces of code, joined to a lot of different code. And in order for it to work properly, we need to understand that the signature may change, and it may be something that you have to do within your aspect in order to ensure that the arguments are something that I can work with. An example of using aspect-oriented programming, in Zen Framework 2 we have an event manager. This is also similar. Symfony 2 has a similar thing. Lithium is using intercepting filters, which are very similar to the event manager. There are a lot of different ways to do this. But in this particular case, your event manager allows you to attach callbacks to particular signals. So I've got dispatch.router.post is my signal, and I'm attaching a callback here. Now what's interesting here is that this is basically for caching. And what I'm doing is I'm checking to see, I'm querying in my cache object. So this is where this is an actual closure in this particular case. That's the use cache portion on the first and second lines. And I grab some parameters out of the event, and this is where querying of parameters happens. I check to see, do I have something I can use? If my request isn't an instance of Zen HTTP request, or I don't have a GET request here, then I'm going to just return automatically. Otherwise, I'm going to create a key out of the request metadata. I'm going to look at my cache, and I'm going to try and load from the cache at this particular case. If I do, I will set my response content and return the response. Otherwise, I just return again. So this is another case. I'm using caching as a cross-cutting concern. I may want to introduce caching at a number of different points. What I've defined is a flex point using my event manager, and by doing this, I'm able to introduce caching without necessarily needing to extend or change anything within my my front controller code. I can just go and introduce this at any point in time, and through querying, make sure that it's something I can understand, and if not, bail early. And if it is something I understand, I can utilize something from the local scope, which is my cache object, in order to affect the program flow. So very interesting, very fun stuff. And that's all we're going to go through right now. Really, at their heart, anonymous functions are relatively easy. It's knowing what the different terminology is, so that when people talk about lambdas versus closures, that sort of thing, what they're talking about. Knowing about the various scoping issues that occur, and knowing when they might be useful. The key reference on this for PHP developers, php.net/functions.anonymous. It's got its own page. You can go directly to it using that URL. It discusses most of the functionality I talked about in here, and anywhere where PHP says a callback can be used, it will refer you back to this page, because anonymous functions can be used anywhere there. You can use callbacks within PHP. Thank you for coming today. I'm going to switch over to the meeting view so I can take a look at stuff coming in on the Q&A. So if you have any questions, now is a good time to ask in the Q&A panel. So going over there. There's not many questions, so that's good. Looks like the main question was restarted twice. Okay. If you use call for calling private methods, would the monkey patch take priority over magic method? So what happens here is it depends on how you're doing it. If you're using __call for calling private methods, it's going to be the precedence in which you identify them within your __call method. So if you say in this particular case that you want to proxy to private or protected methods, you would want to define that logic first before falling back to the closures. On the opposite end of the spectrum, if you want to prefer closures over your closures over the private or protected methods, then you'd put that logic first. So it's really up to you as a developer what's going to have precedence there. Daniel Rhodes, you were wondering about the use keyword. So the use keyword is used to import variables from the current scope into your particular closure. So when you say function $name use foo, the assumption is $foo is already defined in the current scope, and what will happen is the current state of that will then be used whenever you call that particular anonymous function or closure in this particular case. So that's all that's happening in there. It's a lot of fun in this particular case because you can have something that's very stateful. So for instance, you've got a logger, and that's very stateful, and you're just composing it in this particular case without needing to necessarily have like another object or anything. You just compose it into your closure, and it will be available. It's already defined, and if you make any stateful changes to that particular object, they will be reflected whenever you call upon the closure. Daniel Rhodes is asking, with the example of HTML special characters, how different is that to a regular utility function? The place where I would see this being used is particularly in filtering operations, where you want to, for instance, create a filter chain, and the filter chain is really going to have just a single value at a time. What's nice about this is that I don't have to define a separate function with a name of any sort. I can define it on the fly and pass it in. Usually I won't actually even assign it to a particular variable. I just say I'm going to attach this filter, and that filter is going to be a callback in this case, a closure. So it's very interesting. Closure type hint, I saw a built-in. So closure is a class. It's a built-in class within PHP. As I mentioned at the very beginning of the, you may have missed this portion in the beginning with the syntax. Closure is a new class added with 5.3. What it does is it defines the magic underscore invoke method, which makes it actually a functor. But whenever you define an anonymous function, it creates a class, basically defines the body of invoke to be your function, and allows you to set state via the imports, and so it's an actual class. It's a built-in. You should not necessarily rely on it, however, because it's considered a quote-unquote implementation detail. That said, I don't think it's going to go away anytime soon, so you can always type int on it. The problem with that, of course, is that you may want to mix closures with other valid PHP callbacks. Sean Stratton is asking that with traits in PHP Next, should we expect a ZF3 based on AOP practices? I think that's particularly funny because Sean was at my tutorial last week at PHP Community Conference where I talked about ZF2 patterns. We're actually already planning on aspect-oriented practices for ZF2, not ZF3, for ZF2. We can actually implement traits with the next PHP version. We just can't utilize them within framework code without going to ZF3. But we can still compose that code in. It's just that we'll have a lot of repeated code throughout the framework for composing in things like the event manager. That said, it's doable now. Everything is possible now. Traits just make it simpler and reduces the amount of code. Any other questions? I'm going to count down from 5. We're down to our last 12 minutes of the hour, so I'm going to want to finish here so everybody's had a chance. But last call for questions. Not seeing any, so this is good. I will be posting these slides hopefully on SlideShare. If not, I'll be posting them on my blog. I've had a lot of problem with SlideShare in the past 2 months in terms of getting content up there. It tends to have problems converting it to whatever format they have. So if they're not on there, I will post them on my blog, and of course they will be posted on the Zen.com website probably by the end of the week. And the recording of this is usually up within a week or two of the original broadcast, so you can also look at it then. Thanks for joining me today, and I hope you learned something about closures over the course of the webinar. Thanks again.